tell you the most important things you need to know about energy for transportation. Transportation really has two uses for humans. The services we want from transportation is to move ourselves around and move our stuff around. Get goods to us because we need access to goods, or get ourselves to economic opportunity or to educational opportunities, to family, things like that. I'm mostly going to talk about today moving us around because that is a bigger portion of our energy use in transportation. So just looking at transportation sector as a whole, it is the second largest energy end use sector. So when we're talking about end use, these are kind of like the economic sectors of the economy. So we've got residential and commercial, that's really buildings, industrials, kind of a mix of buildings and manufacturing, and then transportation. And you can see it's about a third of our energy consumption, both for the world and the US. So it's a very significant portion of our energy consumption. So given that we're using oil and that is a fossil fuel that has a lot of both greenhouse gases and air pollution impacts, it's a significant contributor both to greenhouse gases, which I'm showing here, and to air pollutants in our communities, where we work, where we're driving. Transportation tends to be a very local source of air pollution, so it has kind of an outsized impact on human health. Road transport is really what dominates in terms of energy use globally. But the efficiency of different modes vary. What I'm showing you here is personal travel efficiency for different modes, and I want to give you a sense that this is the actual efficiency. So this is taking into account how many people are actually riding these different modes. So if you were just thinking about the efficiency of the mode, aviation would be the least efficient, but it tends to be more full than, for example, large cars. So if you are considering it per passenger mile, the large cars actually end up being more energy intensive ways of moving people around. Rails is one of our lowest. Bikes and walking would be even lower in terms of energy use. And of course, the transportation fuel that dominates our transportation sector is oil. I'm showing you just the US example because we have some of that data, but if you looked at the world, it would be a very similar picture. It is why we pay so much attention to our oil prices, because it has such an impact on transportation prices. And it's dominated by a single thing. So disruptions in the supply of oil really impacts the transportation sector. You can see we do use other things, even in the United States, for transportation. Most of this natural gas is used to move natural gas, so it's not for moving people around. A little bit of biofuels, and then you can barely see the little pixel that's electricity, but electricity is a portion of our transportation sector that is dramatically growing. And one of the advantages of electrifying our transportation sector is that we then have a diversity of fuels. And so we aren't so reliant on one fuel, and we aren't so impacted by price spikes in different fuels like coal or natural gas. You have solar, wind, nuclear, all those other things to kind of also get that electricity from. There are a lot of externalities from transportation, and I'm just going to go through kind of the big picture ones, but it's not just the things we've already kind of talked about, air pollution and greenhouse gas emissions. There are safety externalities from transportation in terms of mortality. There's land and water pollution. There's resource use, both for the land. If you think about all the highways and parking lots and things like that, and also for just the large manufacturing industry that provides our transportation modes. Lots of resource use, congestion, stress, pollution, these are all externalities. And then there's also this element of equity and justice in our transportation system. So a lot of externalities for transportation. So let's talk about personal transportation in a little bit more detail. Today's gasoline vehicles really have a very low overall efficiency. And this is partly because they are fueled by a heat engine. Heat engines are inherently low efficiency. This is just thermodynamics because we're using heat to do work. So even if you get as much combustion as you can, you're completely combusting the fuel, you're completely turning it to heat. Using that heat to do work is a lossy way to do things. And so you can see that this is just kind of an average. Less than 1% of the car's fuel, the gasoline that you're putting in the car, actually moves the driver. There's all sorts of losses in the engine. That's our heat engine. There's all sorts of losses in aerodynamics and rolling resistance, things like that. And so for all of the externalities for that fuel system, it is a very low efficiency system. And there are other ways to think about the impacts of transportation. So that's thinking about just the vehicle itself, but transportation is a whole system. And so one of the ways I like to think about the impacts in the levers for improving transportation, because we want to improve it not only from an environmental standpoint, from a service standpoint. How can it better meet the services that we need? There are lots of different levers you can kind of lean on to think about how we can have a better transportation system. So this is looking at embodied energy of our systems, mode switching or telecommuting, vehicle efficiency, the infrastructure around vehicles in terms of timing of lights and things like that, and the fuels themselves. And I've already mentioned electricity, and we're going to talk more about that. But there are lots of different levers. Some of these just take better planning in order to provide a better service and have lower externalities of our transportation system. So it is not just the vehicles, it is the system as a whole. But let's talk about the vehicles and electrification, because this is really the trend that I'm going to talk about for today. If you want more details, you can go watch our full lecture. So electrification of transportation is a very powerful thing, not just because of the diversity of fuels that can now drive our cars, but also because it's so much more efficient at converting that energy to motion. So what I'm showing you here is just one kind of illustration of this. For the electricity that's going in, look at it, almost 90% is going to driving motion. And of course, you have regenerative braking as well. So when you're slowing down the vehicle, instead of having losses due to your brake pads on your tires, and you have heat and you have pollution from that, there's actually particles that come off that. Instead of doing that, you're just using the resistance of the motor as a generator and putting electricity back into your battery. So this is a very powerful efficiency measure that you can do with fully electric or partially electric vehicles that really improves the efficiency. And you can see, because we're not using this heat engine to do the driving motion, this electric vehicle is much, much more efficient. So it's the efficiency, it's the diversification of fuel, and it is taking that tailpipe air pollution out of our communities. So all these are powerful things about electrification of our cars. I often get the question about, okay, yeah, I've got an electric car, but what if it's powered by coal? Isn't that worse? And so I want to point you to this awesome website that is actually provided by the Department of Energy in the United States, where you can go look up your electricity mix for your state if you're in the United States and see how an electric car would compare to its hybrid or gasoline counterparts in terms of emissions. I've got a few examples here. I've got California and the national average. Electric is obviously a lot better in terms of emissions per vehicle, but not a very fair example. So let's look at some very fossil fuel heavy places. This is West Virginia. You can see all electric still definitely comes out better than a gasoline. A little bit closer to the hybrid. And then here's Hawaii, which is a very oil dominated electricity mix. Again, not all electric works out. So the data, you're getting that efficiency that is really powerful in terms of lowering those emissions, even if it's a fossil fueled system. And of course, the goal is that that system, that electricity system, will get greener over time. So unlike an oil dominant system where your oil doesn't get any greener over time, your electricity system definitely could. So this is another advantage of electrification of our vehicles. Another thing that we often talk about is the cost. This is just showing, over kind of a 2-year period of how the cost to fuel an electric vehicle compares to the cost of fueling a gasoline vehicle. Two things to take from this. It's cheaper pretty much anywhere, even in places where electricity rates tend to be relatively high because of all that efficiency gain you get with your vehicle, and it is less volatile. So we are seeing prices in the United States of electricity going up because of some of the policies that are going in place right now and the growth in demand. But it is definitely not volatile like we've seen with the gasoline prices. So those are another advantage of electrification of our vehicles. Okay, it's not all rainbows on our vehicles. There are definitely range anxiety and behavior change as real barriers to mass adoption of electric vehicles. And having, I have an electric vehicle and I've lived in an apartment. Charging infrastructure for apartment living is also another real barrier that is a challenge for electric vehicles. So I just want to make the acknowledgement of that our vehicles have gotten a lot better in terms of range, for example. So our averages are somewhere around 200 miles of range per charge, but it is still a behavior change. You still have to have access to some charging network. Easy if you have a single family home or something like that, much harder if you live in multifamily home. But those charging networks are growing, and we'll talk about that in a minute. We are seeing growth in the electric vehicle stock in the world, everything in terms of both sales and on the road. Much of that growth is driven by China, where their sales are extremely high on electric vehicles. So they're making electric vehicles domestically and selling them a lot domestically. And just to kind of give a sense of how quickly the landscape is changing on new vehicles, this is just showing you a side-by-side comparison for 2019 and 2025 for new vehicle, think of it as sales. These are new vehicle on-road vehicles. And you can see that really, this is only like 5 years ago, we were dominated by gasoline vehicles. Now you can see how much and how quickly battery electric has really grown on this map, and we expect that growth to continue. Another big thing that's changed in the EV manufacturing world is that BYD, a Chinese company, has overtaken Tesla barely as the largest EV manufacturer in the world. So if you were looking historically, Tesla has really driven the growth in EVs domestically in the United States and worldwide. And I would say has dragged some other manufacturers along with it in terms of producing electric vehicles and showing that there's demand. And BYD has done the same. This lovely bus behind me at Stanford is a BYD electric vehicle. So these two companies are really leading the way on electric vehicle manufacturing. And I did want to tell you about those charging systems. So they are growing worldwide. The largest charging networks are what we would call slow or level 2. So they're not super fast chargers, but we're seeing growth in fast and ultra fast chargers as well. And that can really help with that range anxiety. And you can see how much that growth is really taking place in China to meet the needs of that growing electric vehicle system. Finally, I know I just talked about electrification a lot, but it's not the only thing that's happening in transportation in terms of fueling our systems. So we're really seeing electricity in personal vehicles, but in our larger systems, our airplanes, our 18-wheelers, it's really a question on what's going to power those, how are we going to decarbonize those modes, how are we going to decarbonize ships. I think those are still open questions. There's a lot of investigation in e-fuels or synthetic fuels, things that are taking CO2 out of the air, making fuels out of it, decarbonized hydrogen, biofuels. And then, of course, like I mentioned, there's lots of other things that we can do to make our transportation systems meet our needs and be more efficient and less impactful on our planet. If you want to learn a lot more, please go check out the full lecture. And of course, join our Energy Spotlight.